Okay, so today we're going to be working on lesson 5, which deals with finding areas of figures on the coordinate plane. The first piece of this is just discussing distance on the coordinate plane between 2 points using their ordered pairs. We've done this before, so I'm just going to walk through one quick example with you so you can see. And I think that you'll probably choose to count the distance between 2 points instead of using this, so I'm not going to do more than one here. So there are problems like this in your packet and on your homework though, so I do want to show you what it's saying. So if you look at the first row of the table, it's giving you line segment AB. So that's basically saying how far is it between point A and point B. I'm looking at the graph at the bottom of your page. The first thing it says is point, so it wants you to give the coordinates of one of the points. So I'm just going to do A first. So remember with your ordered pairs that it's your x coordinate comma your y coordinate. So to get those numbers, I'm going to start at the origin. I'm going to count over until I'm under point A. So that would be 1, 2 to the left, and that's a -2. So the first number in my ordered pair is -2. And then I'm going to go up into the positive numbers, and I'm just going to count how many up it is. It's 1, 2, 3, 4, 5, 6, 7, 8, and it's talking about the point A right here, the corner. So that would be 8. The other point in the line segment is B. So for B, I would go over to the right, which is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is my first number in my ordered pair. And then I'm going to go up, and since B is directly across from A, that means it's also at 8. Now to find the distance between these 2 points, I'm going to go over to the proof column, and I'm going to use the absolute values of the numbers to find their distance. So if we remember, we look at the numbers that are different. So the 8s are the same in the same spot, and the -2 and the 9 are the two different numbers we're looking at. So -2 is negative and 9 is positive, so they have different signs in front of them, which means I'm going to add their absolute values together to find their distance. So the absolute value of -2 is +2, the absolute value of 9 is +9, 2 plus 9 is 11, so their distance is 11. Now if -2 and 9 had the same signs, I would be subtracting their absolute values to get their distance. So that's the setup of the table. You're going to see a table like that in your exercises, so just so you get an idea of what it's talking about. And just another thing to be careful of too, on the graph with your points, they would be right where they hit. So I'm just putting in the points here. So if when you get to those exercises you want to put in the points, that might be helpful for you. Like I said, I'm not going to go through too many more of these because this is review. So we're going to move on now to the rest of the lesson, which is the main focus. And in example 2, it asks you to plot and connect the points, and it gives you some points to do. It then wants us to give the best name for the polygon and determine the area. So I'm going to start by putting the points on the coordinate plane. Point E is -8, 8, so I'll go over to -8 and up to +8, and that's E. The next one is F at -2, so I'll go over to -2 and up to +5. Make sure you're filling in on your packet as I'm doing so on here. And point G is -7, 2. So over to -7, up to 2, and that's G. So what I'm going to do now is I'm going to connect these points. I'm going to do the best I can here to make them somewhat straight. Okay, and from there we have to determine the shape. So as you can see, it's a triangle, and to be specific, all 3 of the angles are acute, so it is an acute triangle. Now, in order to find the area of a triangle, I would have to know the base and the height. If we look at each one of these sides of the triangle, I can't really find a side where I would be able to count out the base because it's not on the lines of the grid. So since this is happening, what I have to do is that method that we learned in lesson 3, where we draw a rectangle around the outside of the figure, find the area of the rectangle and subtract out any empty spaces. So what I'm going to do here is I am going to draw a rectangle around the figure. Now notice my rectangle is going through all of the points of the triangle and creating that figure around it. So now what I'm going to do is I'm going to find the length and the width of this rectangle so I can find its area. So to do that, I've got points here and here, and I'm going to find the distance between the two of them. Now here's where you could do those ordered pair and the absolute value distance, or you can just count. So to go from this point to this point, I would go 1, 2, 3, 4, 5, 6. So that is 6. And then from this point to this point would be 1, 2, 3, 4, 5, 6 as well. So this is actually a square. So I'm going to do the area of the square first. And that is length times width. So I do 6 times 6 and get an area of 36 square units. Now, remember, we are trying to find the area of just this triangle, the one that we started out with in the beginning. So what we need to do at this point is we need to find the area of the right triangles that we have created, and these all are on the grid line, so it's very easy to count their base and their height, which is why this will make it nice and able for us to do. So we've got our squares area. We're going to find the area of each of these 3 triangles and then subtract them from the square, and what's left over will be our pink shaded in triangle that we needed to find. So I just numbered the triangles. It really doesn't matter which one you do first, second, or third. Remember though that you do want to do the formula for each one so that we don't forget to divide by 2. And then we're just going to count our bases and our heights and plug them into the formulas. So for triangle 1, I use this triangle over here. Our base is 1. Our height is the full length, so from point to point, I know it's a little sloppy, it doesn't look open, but it is the full length, and that side length is 6 because this side length is 6. So 1 times 6 divided by 2. 1 times 6 is 6, and 6 divided by 2 is 3. Triangle 2, and again, it doesn't matter your base and your height as long as you're using the sides that are connected with that right angle. So this one is 1, 2, 3. And then it's the full length. I know once again my line's not very straight, so it doesn't look like it goes all the way to the next point, but it should. So it is 6 across on that side as well. So we get 3 times 6, which is 18, and 18 divided by 2 is 9. And then for the last one, we have 1, 2, 3 as either the base or the height. And then the other side is 1, 2, 3, 4, 5. It just goes to this point, not right here, not the full length. So 3 times 5 is 15, and 15 divided by 2 is 7.5. So now my suggestion would be to first add the areas of the triangles together and then subtract from the square. So we've got 7.5, 9, which I'm going to change to 9.0, and 3, which I'll change to 3.0. Add them together to get 19.5 for the area of the 3 triangles. We're then going to subtract that out of the squares area, so 36, and I'm going to change that to 36.0, minus the 19.5. And that gives me an area of 16.5 square units for our pink triangle. Okay, let's look at the next one. So example 2, same directions. We're going to plot some points, give the best name for the polygon, and determine the area. I'm just going to make mine a little bit bigger here. Okay, so the first point is 1, negative 4. So I'll go over to positive 1, down to negative 4, and that's point P. Q is 5, negative 2. R is 9, negative 4. S is 7, negative 8. And T is 3, negative 8. Okay, so now I'm going to connect my points. I'm going to try and do them as straight as possible this time so that I'm not as sloppy on my outside triangles. Okay, so we've now connected the points, and to name the shape, the best way to do this is to count the number of sides. So we have 1, 2, 3, 4, 5 sides. 5 sides means it's a pentagon. Pent means 5. So in order to do this one, we have to do the same process as we did the last one. We have to draw the rectangle around, subtract out the empty spaces from the area of that rectangle. So again, we want to draw through the points to create our rectangle. Let's count the side lengths now. So from this point to this point, we have 1, 2, 3, 4, 5, 6, 7, 8 as a side length. So of the rectangle we're looking at, we have 8 as one side, and as the other, 1, 2, 3, 4, 5, 6. So the area of the rectangle that surrounds our pentagon is 48 square units. Now in this problem, we have 1, 2, 3, 4 triangles. What I'm going to do is I am going to count my bases and my heights now, and then we'll find the area. So each one, remember, they connect at the corners for the right angles. So counting our bases and our height for triangle 1, 1, 2, 1, 2, 3, 4, stops right here. For 2, it's 1, 2, 1, 2, 3, 4. For triangle 3, it's 1, 2, 1, 2, 3, 4. And for triangle 4, 1, 2, 1, 2, 3, 4. So if you notice, all 4 of those triangles have the same base and height. So what I'm going to do is I'm just going to find the area one time. So base times height would be 2 times 4, which I will get 8 from, and then divide by 2, which is 4 for each triangle. Since we have 4 triangles, I can either do 4 times 4 or 4 plus 4 plus 4 plus 4 to get the total area for all 4 of these triangles as 16. Then I'm going to go ahead and subtract that 16 from the 48. So this is the area of our rectangle, and this is the area of all the triangles. And when we do that, we get 32 square units. Okay, so it may be beneficial for you to count your bases and your heights of your triangles at the same time. So if any are the same, you don't have to keep showing the work for all of those at the same time. Even if you just have 2 that are the same, you can multiply your answer by 2, or 3 is the same, and so on. Okay, let's look at one more example. This next example is a little different. It says 2 of the coordinates of a rectangle are A, 3, 7, and B, 3, 2. The rectangle has an area of 30 square units. Give the possible locations of the other 2 vertices by identifying their coordinates. Use the coordinate plane to draw out and check your answer. So I'm going to start by drawing these 2 points. So we've got A at 3, 7, so over to 3 and up to 7, that's A. And B is 3, 2, so over to 3, up to 2, or B. Now, we're told that the area of a rectangle involving these 2 points is 30 square units, so meaning that this is the side of a rectangle. So I'm going to start by finding the length of this side. Now again, you can either use the distance between 2 points like we did in the beginning, or you can count from point to point. So 1, 2, 3, 4, 5 would be the length, and again, if we did do the 2, same sign of 7 and 2, so I would subtract their absolute values. 7 minus 2 is 5. So same answer, different ways of doing it. So now I know that I have a rectangle. I know the area of a rectangle formula is A equals length times width. I know my area is 30. My length is 5, or my width, it doesn't matter. And I'm trying to find that missing dimension. So to solve this, which I'm sure most of you already know what number times 5 is 30, but I'm going to show it algebraically anyway, it would look like this. And 30 divided by 5 is 6. So what that means is we need our other side of our rectangle to be 6 long. So I can take from point A or point B or both and count 6 units in a different direction. So I'm going to start by counting 6 units to the right. So from B, 1, 2, 3, 4, 5, 6 would go here. And from A, 1, 2, 3, 4, 5, 6 would go here. So if I were to make this rectangle, it would look like this, with this side being 6, so 5 times 6 would give me an area of 30. They're looking for the coordinates of the other 2 points that would finish off this rectangle. So starting at the origin, I would be going over to 9 for both points. And then for one of those points, I'd be going up to 2. And for the other point, I'd be going up to 7. So 9, 2 and 9, 7 would be one of the possibilities of an answer here. The other thing we can do is instead of moving to the right 6, we could move to the left 6. So starting at B, and I'm going to just change my color here, counting to the left 6, 1, 2, 3, 4, 5, 6 would put me here. And counting from A to the left 6, 1, 2, 3, 4, 5, 6 would put me here. Here would be my other rectangle that I could make. This is 6, so 6 times 5 gives me 30 that way as well. So the ordered pairs that would work for this rectangle are over to -3 for both. And for one, up to 2. And for the other, up to 7. Okay, so this is a different type of problem you may see. Again, it's using the coordinate plane and distance to solve some problems. You have a play posit that you can be working on right now, so please get started on that. Look back to your notes if you need to. Good luck.